This episode of the .NET Core podcast is brought to you in part by RJJ Software. RJJ Software is dedicated to helping you realize your company's digital potential through innovative solutions using the latest technologies. Utilizing the latest in .NET and cloud technologies, we can help you build the solution your business needs on time and under budget. We have world-class experience in cross-platform development using the latest iterations of the Microsoft technology stack. This includes .NET Core, SQL Server, and Azure. Is Azure not your thing? That's fine, because we have experience in AWS, GCP, Linode, and DigitalOcean too. We know what it means to have to be able to iterate quickly and how important DevOps practices are when it comes to remaining agile. As such, we have experts in the major build and release pipelines, from Azure DevOps to AWS, from Netlify to Travis CI, AppVeyor, and everything in between. So get in touch today at rjj-software.co.uk or check the show notes for a link. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, SignalR, and not forgetting the .NET Core community itself. I am your host, Jamie Caprockman-Taylor, and this is episode 70. Picking the right Azure resources with Barry Luijbregts. In this episode, I talked with Barry about how to pick the best Azure-based resources for your application stack. Barry is an independent software developer, Pluralsight author, the host of the Developer Weekly podcast, and a Microsoft MVP. So let's sit back, open up the terminal, type in .NET New Podcast, and let the show begin. So the first thing I'd like to say, Barry, is thank you ever so much for spending some of your evening talking to me about what we're about to talk about. Hopefully we get to talk about Azure and the different cloud offerings and how you pick the right one for your project. So it's great to have you with me because if I'm completely honest, I feel like I could look at all of the Azure offerings and go, yeah, I still don't know which one I need to pick. I'll just go with web app. That'll do.
Yeah, that's what most people do. Yeah, absolutely. Thank you very much for having me on. It's an honor, really.
Oh, thank you ever so much. So what I thought is perhaps we could start with a little bit about you, and maybe if you could sort of introduce yourself to the listeners, if that's all right. So then everyone knows, who it is they're listening to and what it is that you do and all that kind of stuff. Is that okay?
Absolutely, yeah. So my name is Barry, and I usually don't pronounce my last name. It's Luijbregts, aka Azure Barry. So I usually don't pronounce my last name because it's difficult in English, and my wife always says that we should have taken her last name, which is Hannon, which is much more easy because she's from the UK. But okay, that's a separate topic. I'm a software developer and sometimes architect, depends on which role I do, because I'm a freelancer as well. So I serve many different clients in all sorts of projects, usually nowadays Azure related. And I do that I've done that for many, many years. I've always been a software developer in the Microsoft space. So with .NET, from the early start of .NET up until right now, it's an amazing time to be a .NET developer. .NET 5 is about to come out, .NET 6 after that. We have all these amazing tools like Visual Studio. Constantly amazed. If you look back, it's so awesome that this stuff exists. Visual Studio Code and all that stuff is just amazing. So my focus now is on Azure, and then on the developer part of Azure, which is still huge, because Azure in total has, 160 something services, including all the infrastructure services. And then maybe the developer services might be 100 or something. It depends on what you count as a service and what you count as a feature. I try to keep up to date with all of that and use that for my clients and try to assimilate all the information that comes out of Microsoft for Azure so that I can advise my clients into what they can use the best for their projects and also use it myself within projects that I do for the clients. And then I also try to teach those topics in Pluralsight courses that I also create.
Excellent. There's a whole bunch of stuff to unpack there, but I think you're absolutely right. I think right now is the best time to be a .NET dev. There are so many things out there that we can use. There's, you said yourself, Visual Studio, which is part, if you're a small team or you're working, or I'm not going to get the licensing right. Please view the licensing yourself. But my understanding at this time, as we're recording, is if you're a small team of maybe up to 4 developers or you're doing open source, you can get Visual Studio for free. There's an enterprise version, there's a community version, there's Visual Studio Code, which is a wonderful editor that can practically do anything. All of that, Visual Studio Code is free, right? And all of the things that Visual Studio can do, it's kind of like a Swiss Army knife of development tools. It can almost do anything. Right? It can edit almost any type of file. It can open database connections and visualize all sorts of stuff, connect to the cloud, all sorts of stuff that it can do. It can do Docker things. You can even interactively debug an application that's running inside of a Docker instance from Visual Studio. It's just the amount of things that it can do is just, I don't want to say insane, but it's kind of mind-boggling what it can do.
Yeah, and we really need to appreciate that a bit more, I think, because we are so extremely spoiled. If you look over the fence a little bit, like what, let's say, Java developers are using, I love you, Java developers, but oh my God, I'm so sorry for you guys. The IDEs and stuff, it's so much worse than Visual Studio, as in usability and the features that it has. We are extremely spoiled with what we have. It's crazy.
Yeah. I feel as though that's partially because I get the feeling that Microsoft dog food all of their tools. So, Visual Studio is used to build Visual Studio and to build .NET and to build C# tools and Windows things. It kind of makes sense that, hey, can we iterate on this and make it better? And since, Sun and Oracle are the sort of overlords of Java, but they don't tend to produce as many services and applications and things as Microsoft do, at least for, I haven't had that much experience using them. So I guess they don't have that much experience in dog fooding their own stuff. I know of Oracle because of the database technology, and I know of Sun because of Java, but that's it.
Yeah. Yeah, absolutely. And it always feels a little bit like, Windows 95 applications that you open. It's just not a nice feeling.
Yeah. Yeah.
So, we're standing on the shoulders of giants with all the stuff that we're currently using. And I think we need to appreciate that.
Oh, absolutely. And not just that, like the third-party tools. So I'm a big fan of using JetBrains Rider. And obviously, if you're a C# developer, you've likely heard of ReSharper. And just those two tools are just, I feel like that they should be included in everyone's tool set, but not relied upon, right? Like ReSharper is a wonderful tool, but you shouldn't really rely on it to do your work for you. But you can use it as an education tool as well. You can say, okay, how can I refactor this? Oh, I get that now. I understand why you're saying that I should replace this for loop with a select statement, because I get it. It makes more sense. It looks a certain way. Absolutely. But just going control dot, yeah, check it in. Not so much.
No, I totally agree with that. You absolutely need to understand what the tool is doing, instead of just having it refactor and then say, well, I don't know what it did, but it's probably good, right?
Exactly. It's like, a friend of mine fancies himself a writer, and he'll write a whole passage of stuff and then just throw it at the spell check engine and just accept everything and then put it out there. And I'm like, I'm not a writer, but this doesn't make sense to me. Maybe you should go back and try again.
Yeah, that's probably not a good idea. No.
Yeah. But yeah, I get the feeling that tools like ReSharper and part of the functionality of ReSharper has been included into Visual Studio. So those kinds of tools, those refactoring tools, they're great. They're a bit like chainsaws in that respect. They're really good at carving down the cruft of something. But if you use it wrong, you're going to lose a finger.
Oh, yeah, absolutely. Yeah, you're right. Lots of ReSharper is now included into Visual Studio. Latest version, 2019 or 2019.6 or whatever, because it releases every week, I think, or every other week, which is great, Like I did a course on what's new in Visual Studio 2019 when it first came out. They had IntelliCode. Have you ever used that?
Is this the artificial intelligence engine that tries to learn how you're writing code and suggest things?
Yeah, which it's really it's pretty clever, and I think they revamped it a little bit and now brought it out again to just get people to use it. But it's really clever because so you can train it on your own code base, especially if you have a large code base. This is very useful because then it will suggest in IntelliSense, hey, you probably want to use this method of this class in this particular context because that's what you did in lots of other places as well. I love that stuff.
So we're almost at a point where we can go file new file control dot insert code, right?
Yeah. Almost, yeah.
Excellent. Yeah. Leveraging the power of the cloud, which I suppose we're going to talk about in a minute, but yeah.
Good segue.
You're absolutely. Yeah. But yeah, the amount of tools and cloud things and all of this stuff is taken care of for us, right? I mentioned earlier on that, I'll just go, give me a web application and I'll just throw my code at it. And I literally don't have to do anything. I don't have to worry about a server. I don't have to worry about firewall things. I mean, I can if I want to, but I don't have to worry about that. I don't have to worry about getting a URL. I don't have to worry about getting a TLS HTTPS certificate. I don't have to worry about CI/CD. That's all taken care of for me. And I mean, that's not just Azure. AWS does this too, right? And Google Cloud, they all it's all wrapped up in slightly different ways, but they all do things they all achieve that same goal of how do we get this app out there or this service out there for people to use. And I think whilst that's wonderful, I push a button and it just appears. It's which button do I push? Because the cloud itself is a huge subject, right? I mean, let's talk about how it started initially as just the marketing term, the cloud, comes from how we used to draw block diagrams of how the application would work. And there would be a literal picture of a cloud that represented the internet. Server over here, a cloud over there, and a database there. That's where it came from, right? But like for developers who spent all of their time working on-prem, going from I have a server in a data warehouse or maybe on the premises and I'm moving everything to the cloud. Like, how am I going to pick the right thing? Like, how do I even pick Azure, AWS, Google Compute, Linode, DigitalOcean? There's a whole bunch of them, right? Almost everyone's doing platform as a service now. So I guess, what the heck? How do you even pick one?
That is very difficult. If you look back when all the big players started to create the cloud platforms, they really started to create utility computing. So, computing as a service. And they all started out with virtual machines, basically. So now you have a virtual machine on premises or even under your desk on a server running somewhere. That's your machine, that's your server. And we're just going to have it now in the cloud. And then the only benefits they had in the beginning was because it runs in the cloud, when it goes down, we'll make it go back up again. So you don't have to worry about all that stuff. And also, it's more secure as well because, we run this whole thing and we have firewalls and we have all this stuff and people that know about security. So you don't have to do that all yourself. You don't have to put a physical firewall between your desk and the server that's under there or something. So that was the first step, I think. And then they all went on to create more and more powerful and easier to use services that basically take care of all the plumbing of all the stuff. Like you said, you just click on something like a web app and then it's just running and you don't have to take care of the service. Basically, you don't have to take care of running it. You just run your service. You don't care about the infrastructure. You can care about the infrastructure. You can run a VM, for instance, and then have lots of control over the virtual network and all that stuff, but you don't have to if you don't want to. You can just run your app. And that's the lovely thing about the cloud. So you can just create your application and just put it somewhere and then it just runs. And it takes care of load balancing, high availability, scaling automatically, all that stuff that used to take weeks and months to configure web farms and all that very, very complicated stuff with sharing session state, which it's a horrible thing to do. And now it's all just a slider where you just scale up and down. But to come back to your question, how do you even pick a cloud provider? Well, now you rattled off, I don't know, 5 or 6 or something, but there's just a couple of very big ones that basically all do the same. And that's Microsoft, that's AWS, so Amazon Web Services, and that's the Google Cloud. There are a couple others that trail beyond that, but they really don't have a very complete service offering. But those 3 big ones really have a more comparable service offering. They basically do the same thing at basically the same prices, really. It differs a little bit, but it's all basically the same thing. What I usually advise customers to do is to pick what you're comfortable with. If you are working with the Microsoft stack, you've always worked with Windows servers, or SQL and licensing from Microsoft. You already have the connections with your Microsoft Office. Go with Microsoft. If you're not comfortable with Microsoft, it doesn't really matter what you do in development-wise, even if you do Java or even if you do .NET, you can still go to AWS as well, because they can run anything as well. It doesn't really matter. Same goes for Google as well. But if you really want to have a very reliable partner in cloud, that it is their main business model to run, then that's Microsoft, because Microsoft nowadays is cloud. They kind of make money a little bit with Windows and Office, but their main business model right now is the cloud. That's what they do. If you look at Amazon, they make a lot of money with their cloud. They do lots of other stuff as well. They send packages to your house. That's fine too, but their focus is not per se only the cloud. Google, the same thing. They have a cloud business, but they also do lots and lots of other stuff. So you have to take that into consideration a little bit. I'm sure they're all very good, of course, but I like to put my money into Microsoft because they have their extreme focus on the cloud. If that goes wrong, there's no Microsoft anymore. So they will definitely keep investing in that. They will trying to keep it better and more organized and more useful than the other providers. And I think they're doing a very good job at that at the moment.
I have to agree. I know that, so I don't like to refer to the ongoing situation as anything other than the ongoing situation. But when that whole thing kicked off, I know that a lot of businesses immediately went, right, we need to go to the cloud and set up Teams or Slack or something to get everyone involved. And I know that almost the entirety of Microsoft's Office suite is kind of mostly powered by the cloud, right? And the fact that people could take all of their business online, send all of their staff members to work, send all of their teams to work from home, fire up lots of Teams instances, and everything just kept working, right? I was involved with things other than development work that wasn't any kind of work, but I was sort of consulting and giving advice on a lot of things that were nothing to do with development during the early parts of the unfortunateness, the current situation, and just jumping from one team's chat room discussion to another, all of these conference calls, and it just worked, right? And that's all the cloud, right? All of that is powered by the cloud. That you can't get away from that. Skype, Teams, I think it used to be called, was it Lynx? It used to be called, Lynx, sorry, SQL Server, all of this stuff, everyone's apps that they threw up onto Azure, all of these test apps for, hey, I've just made a Blazor thing, or I've just made a .NET Core thing. Everything kept working, which is just amazing when you think about it.
Yeah, but they've been doing this for a while as well. Like, remember Amazon Messenger?
Mm-hmm.
That was also the cloud.
Mm-hmm.
It was early versions, but it was Microsoft data centers. So they've been building and running their own data centers for decades now at extreme scale. Because everybody had it back then. And Hotmail as well. Another extremely popular service. I think it's still around. I have no idea. Oh, it's Outlook.com now, isn't it?
It is, yeah.
That's what it is, yeah. But they've been doing that for a while. And they developed this stuff themselves. And they keep developing this stuff. Like they have Project Natick, for instance, which is where they develop data centers that can be deployed under the water, so in the ocean. Because they found out that a lot of people live near big waters, so near the ocean line or near big lakes or something. So if you can deploy smaller data centers there, then you have more coverage, which means less latency, so less time that signals need to travel over routers and wires and stuff, which just saves us milliseconds per request, which adds up to lots and lots of time, which makes things significantly faster and also more reliable, because when one goes down, another one takes over. So they've been building this huge infrastructure of data centers all over the world for decades now, and they have way more data centers than AWS and Google combined even. And they can now leverage it, especially, like you said, with the current situation. Everybody goes to the cloud. The digitalization of the workspace has been in a hyper speed. And so Microsoft has been able to deal with that. And everything still works, which is incredible, you know. That's the cloud for you. It just makes things work. It takes care of all the plumbing, all the boring stuff, so that you can do whatever you need to do. Is it like a Teams meeting or deploying your app? That's what the cloud does.
Yeah, and not just that. Like, one of the things that I thought of when you were talking about the underwater data centers, and let's shave a few. Well, I don't want to reduce it, but let's reduce the time it takes to get the data out of the data centers. And then I think, well, I can have a database based in the UK and a database that's maybe based in Western Europe that are hundreds of miles apart, but they are automatically synchronized, you know, using ACID technologies and stuff. So I can I can have one instance of my app that has the UK data center SQL Server instance as its main instance. And if that ever goes down, it just silently switches to the Western Europe one. But the Western Europe one and the UK one are kept in sync for me automatically. And everything's backed up as well, right? So I don't have to go in and go schedule a backup, because as far as I understand, it's done on a transactional basis. So the backups are taken for every transaction, I believe, and each action is a transaction. So, somebody wrote something to the database and it broke it. Okay, let's just rewind to before then and change that and then move forward again. It's glorious. Not all of that. All of those difficult ops related things are completely removed. They're all taken care of, regardless of Azure, AWS, Google Compute. They're all sort of, like you said, they're all offering the same thing, right?
Yeah, they're basically offering the same thing also in terms of reliability. So what you're talking about is when you have an Azure SQL database, you can turn on geo-replication, which means that you have another instance in another region, like in Europe or in the US or whatever. And then it actively replicates data from your main instance to that other instance. And that other instance is read-only until you fail over. So if your instance ever fails, then you can start reading from that application. And it's magic, really. And even within your own region, without you having to configure anything, out of the box, when you spin up a new Azure SQL database, it backs up everything in 3 times within the data center, on storage, because it's just on Azure storage where the actual data lives. And then it also backs that same stuff up 3 times in another region in case that region fails. And that's just the standard Azure storage backup without you doing anything really. And then it does, like you said, transactional backups, and also every hour it takes a full backup of the whole database without you configuring anything. That's amazing. And you pay pennies because it's storage, and storage is extremely cheap.
Yeah, I do remember one of my older roles was sort of early DevOps days. So, you know, a couple of years ago. And it was, hey, we have all of these database instances in lots of these data centers, and we need you to sort of come up with something that unifies their backups technologies, their backup strategies, and shift all of the backups from those data centers because it's slowing them down and making them more costly, and put them somewhere else. And I spent ages trying to figure out how do I, you know, maybe a backup system that would fire at 2:00 in the morning and it would collate everything and throw it over here. Yeah. Well, what if someone switches that server off that I'm trying to back up from? Or what if the backup gets 95% of the way over and then the file that it was transferring, the transfer was dropped or whatever? There's all of these things you don't think about until disaster strikes. And I love that someone or a large team of someone's have figured this problem out for me. I just get on with the difficult part of writing the app and deploying it. And even then, the deploying it, like I said, right click, publish, done.
Yeah, exactly. And that's the thing, isn't it? Because these are extremely difficult problems. Dealing with backup, it seems simple, but it can become extremely difficult. What if your database is very large? It takes maybe hours, maybe it takes, who knows, so you have to do it incrementally. What if somebody turns the server off? So Microsoft and all the other cloud vendors, they think about this stuff. They have been doing it for decades now. So there's best practices on their side so that you don't have to do it. And like you said, you can just deploy your app and focus on your app. Mm-hmm. And that's the power.
It is. But then I suppose, in your opinion then, before we get on to like, how do I choose the right thing? Should there be a point during requirements gathering or that early planning stage of which cloud or which application within the cloud or which resources within a cloud do we need? Or is it just a case of we'll just write the app and then we'll split it up later?
No, definitely. Yeah, that's absolutely part of it. So if you are, let's say you are designing your solution, which consists out of, let's say it's a web application or something. So it's an app that you write, let's say in ASP.NET Core. So that's a bit of code you have there. It needs to live somewhere, but it has requirements, right? For instance, it needs to be up 99.99% of the time, or maybe you need it to be up more. And it then has data, and that also has requirements. Is it document data? Is it relational data? Is it something else? How large is that data? Do you need that data in multiple regions as well? Or are your users just in one region? Are they only in the UK, for instance? Or are they distributed globally? And do they then need to be able to write something in the UK and instantly see the same thing in the US, for instance? Those are things that you need to take into consideration at the start. So at the start, you need to pick your Azure services that fulfill all of those requirements. Because there you also pick, well, do I need a lot of control, for instance? Do I need to install weird stuff? Like maybe it runs on .NET Core, but maybe you need all sorts of weird things that only run in a VM, for instance. Wouldn't recommend it, but you never know. Maybe you're deploying some legacy thing. I don't know. So at that stage, you already need to pick. And then you pick between a web app, let's say, or maybe it needs to be in a container or a VM or something else.
Sure. And I guess things like if it's using Service Fabric or, like you say, if there's some kind of orchestration required, you have a bunch of Docker instances and you need to have it all scalable and, send out. If you're building, let's play buzzword bingo. If you're building microservices that are going to be infinitely scalable and always going to be on and, they're going to be completely transactional. It doesn't matter if one of them dies, we'll just bring it straight back up. Well, you need to know that ahead of time, right? It's pointless writing a monolithic ASP.NET app if it's got to be inside of Docker containers that is orchestrated by Kubernetes or something similar, because it just is not going to work, right?
No, you got to make a lot of very different choices when you're actually creating your application. So you need to know that up front. But it needs to be driven by the requirements from the business. So how up does this need to be? And what do we actually need to run? And from there, you take a look at, well, which technologies can actually fulfill those requirements. And not the other way around, which happens a lot, like, we're going to do microservices. And it's all in Docker, and it's all containers, and Kubernetes, because Kubernetes is cool. We don't really know why we're using it, but it is just so cool. Look, business. And they're like, what is this? I just want it to run. I don't care about Kubernetes.
Yeah, right.
Who cares? I just need it to run.
Yeah, I've seen a number of projects in the past where either the developers or the company behind the project have gone, we need to be Netflix to start with. And I'm like, all you're building is a blog. That's literally all you're building. That could literally be a static site. You don't need microservices and all of this crazy architecture. You don't need messaging systems. You don't need an event queue. Why have you got an event queue? It's a blog. Why does a blog need an event queue? I don't understand. And I feel like sometimes there's this almost techno joy. How can I use all of these hundreds of different components in my application? and it seems a bit silly, really. I try to work the other way around, so I try to work upwards instead of going at the top. I'm going to, I've seen someone do microservices, Vue.js, and Node, and all of these hundreds of pieces of technology, talking to Blazor, talking to DocumentDB, and it's just this ridiculous map of technologies. And they've built a brochureware single page app, like a single page of HTML. And I'm like, that is amazing that you've been able to tie all of that together. But I can go angle brackets, HTML, close angle brackets, body, angle brackets, and I'm done.
Yeah, keep it as simple as you can. Because the more components that you introduce, the more things that can break and will break at some point. That's just how it goes. And not only that, also the more it will cost. Not only per month, but also operational. Somebody has to take care of all that stuff,
Absolutely. But with that in mind, then, so we've talked a little bit about how you have to figure out what you're going to build first. There's a couple of different methodologies for building apps, right? We've mentioned monoliths and microservices, and I've got written down the 12-factor app. Because the 12-factor app and cloud architecture are kind of intertwined, is this something that I need to know as a developer before I even start my application if we decide to use Azure? Or can I'll throw something out there, get a demo version, and then maybe we'll split it up afterwards? I mean, everyone knows that a minimum viable product is going to be the product, right? But let's say we live in a perfect world where you're allowed to release a beta and it stays as a beta, and the actual released project is different, right?
Yeah, well, definitely never release your MVP. But I've seen that happen a lot as well, because it's so cool and it works so well. So we're not going to throw that all away because it was months of work.
Absolutely.
So, but before you start to develop stuff and architect stuff for the cloud, you need to know about design patterns, right? So you already needed to know this, but now it is more prevalent. For instance, when you're talking to a database, it will fail at some point. You will have a transient error, which is an error that will resolve itself, as in a hiccup in the connection from you to the database, for instance. You do a call to a database and it fails for some reason, but the next time you call it, it works. So you need something for that. You need to have a retry mechanism in your code. Now, luckily, let's say if you're using Entity Framework, it's baked in there. And lots of other SDKs have the same things, but there is lots more where that came from. So things just fail at some point, and that doesn't mean that the cloud is something that always fails. No, your server on your desk also fails. If you bother to look at it, actually, and probably fails much more than the cloud. When in the cloud, things start up again, and instances where things are running on, like an Azure SQL database, might change because they might be updating some underlying infrastructure or something, and for a millisecond just something changes and the connection might just drop. Could happen. And that's not a bad thing, but you just need to be prepared for that. So you could use Entity Framework. There is also other things like Poly, for instance, which is a third-party library that does retry, circuit breaker, all that good stuff. And there's lots of cloud design patterns that you need to be aware of to do things like this, including offloading things to CDNs, using a queue if you really need to, of course, not to just use a queue, but to introduce reliability in your messaging, as in if you want to send something to a database and you have many things coming in and you need to all send them to a database, maybe it's a good idea to put them on a queue so that the database or the background process can then pick those things up in its own time, instead of having to do it real time and maybe fail at it because there's too much load on it. You can do it in its own time, process it, and then it's done. Depends if that's possible, of course. But yes, you need to learn about these type of design patterns, and so cloud and reliability, performance and availability programming, let's say, before you actually start to design for the cloud. But in my opinion, you've always needed to know this. This is nothing new. But now it's just becoming more obvious that you actually need to use it. But your servers always went down.
Yep. And even then, even in a perfect system, there's going to be, like, you can't protect for everything, right? Someone's going to trip over a cable and pull the cable out and the machine goes off. What happens then? Or some strange weather pattern brings about some kind of subatomic particle thing, and you end up in Star Trek land talking about subspace and all this kind of stuff. But these kinds of things can happen, and it ranges from the whoops, Jane has fallen over the cable. Let's go help Jane. Let's make sure she's okay. Oh, wait, she's taking out the server as well at the same time. Let's plug that back in and wait for it all to start up again. All the way up to, I believe there was a time a couple of years ago where there was a storm, not at a data center, but near a data center, which took it out. And it's crazy to me to think that a storm that is a couple of kilometers away from a data center has the electrical power to wipe out a part of some business, right? Let's say 50,000 people can't access Netflix because there was an electrical storm near, not at the data center. That's crazy to me to think that there's that much infrastructure in place. But then none of those users would have realized because there's backups for the backups for the backups, because these ops geniuses have taken care of it all for us, right?
Exactly. But that also meant that people that programmed Netflix, in this example, also programmed it to be reliable and to retry things when that database went down. Because maybe the database went down, you retry, and then you redirect it to another database, you retry, and then it works again. So maybe you see a little bit of a glitch or something where your thing loads for a couple of milliseconds longer, but then it works. But things go down. It's that simple. And whole data centers sometimes are wiped out. Nature is strong. You see it in the US right now. There's new storms and stuff. I'm sure Microsoft looks a little bit at that and doesn't plant data centers in Hurricane Valley or something. But still, stuff happens.
I'd like to take a moment to tell you that this episode is sponsored by Datadog. Also, stick around for the next 30 seconds to find out how you can get a free t-shirt. Datadog are a monitoring and analytics platform which monitor your infrastructure, application performance, and log management. Are you looking to move to the cloud, microservices, or .NET Core? Datadog can help with that. Their distributed tracing and APM provide end-to-end visibility into requests wherever they go, whether it's across hosts, containers, or service boundaries. See it for yourself. Start a 14-day trial today and Datadog will send you a free t-shirt. Find out more at datadoghq.com/.NET Core. That's datadoghq.com/DOTNETCORE, or check the show notes for a link. So we're saying that the 12-factor app and things like this are more like design patterns, that you need to know these things anyway. And that, I feel like I'm just echoing what you said, right? But it's true. All of these things are taken care of for us by the tools and libraries that we're using when we assume it's going to be on one server or on one instance, right?
Yeah.
But as soon as you have two boxes running the same software, and a user can be redirected to either, and there's some shared state or some shared database, or so, like there's the old problem of we have two users accessing the same record in the database at the same time, and they're both writing to it. Well, take that problem and then say, well, you're not just messing with one database now. You've got 15 of them and they're all geolocated in different places. And each of those 15 databases is connected to, 30 copies of your application. And that each of those 30 copies of your application have 200 users at the same time. And just what? Do I need to, as a developer, worry about that huge case there, or should I start with just, okay, what happens if the database dies?
Yeah, the latter. So keep it small, because yes, that can all happen, and you don't know. You should assume that your system is distributed. So services live external from your application, and data should live external from your application. As in, you're not saving stuff on disk anymore. You're not writing to the registry anymore. You're not saving stuff in your local memory anymore. That should all go, because you should assume that your machine can go away at any time, because you might scale, for instance. Then you have two machines. What are you going to do with the state that's in your memory? You need to copy that or something. So you should have that somewhere else, in an external cache or external storage or something. Once you have that thinking that you cannot store anything local anymore, including session state, which you shouldn't use anyways, anymore at least. Back in the day, I did it. It was in ASP.NET Forums, of course. It was super cool. But that stuff can't live local anymore because your local instance can just go away. But keep it simple for yourself and don't get overwhelmed by thinking, oh, geez, I now have 200 of these and then there's 2 caches somewhere and then who knows, this thing might scale out to 10 instances or something. Yeah, you cannot predict that, but you should just assume don't store anything local anymore and you'll be fine. Plus also remember, most of the things that we use, if we use standard Microsoft libraries like Azure libraries to talk to Azure Storage, they already have retry mechanisms. And they already can be configured to use alternative locations. As in, if your local region doesn't work anymore, it will automatically ping whatever coupled region in Azure is there without you doing anything. So that just works out of the box, including Entity Framework does that also for you.
Sure. I do love that that ability to have all of your things in multiple different places and have the failover. There was a project I worked on not so long back where I'd said to I designed this system and I said the config, so like app settings.json, is not going to be deployed with the app. The app, it's going to have an app settings.json, but it's going to use Azure config, right? So then when we need to change the configuration of all of we were releasing 50 different microservices. They were all using common bits of config. When we need to change those things, we don't need to then redeploy every single individual microservice, switch them off and switch them back on. We literally change this one central thing, change the connection string there, and everything is automatically updated for us. And then if that one thing dies, it's already replicated umpteen thousand times. So it blew my mind whilst I was describing it to them. And they were like, but what about the file? I don't understand. Where's the config going? I said, it's going in some esoteric place. It's the cloud. Don't worry about it. It's over here. Don't worry about it. But yeah.
It's external. It's not on a local file anymore. It's in another service. That's just what it is.
Yeah, I tend to think of anything that's not happening right now in the code that I've written or the code of the framework or any libraries that are pulled in. Everything else is ephemeral. Like you said, it can go away, right? If it's not happening right now in memory, it doesn't exist, is how I try to think about it when I'm designing the applications that I write, because it doesn't, right? When I was looking into Docker a few years back, I was like, okay, so you don't write anything to disk because even Docker, like the documentation for Docker says it can die at some point. We don't know. Docker will literally crash and we'll restart it. Don't worry about it. We'll take care of that for you. But do not write files to disk because you'll lose them. And I was like, yeah, that makes perfect sense actually. Because
it does. Yeah.
Yeah. Excellent.
Yeah, it does. It's a little bit of a shift of the traditional way of thinking, where we always thought that, well, my machine is going to be here forever. But that's just not how it works anymore, because we're agile and we can scale. Yeah.
Well, I did that this afternoon. I had to wipe my Windows machine that I do some of my development on. And obviously all the files that were on there are now gone, right? Luckily, I had absolutely everything in source control. I even have the config for the machine in source control. So it was just reinstall Windows, pull some stuff from my local Git server, and it's back to how it was, right? And I think Windows can do that for you now anyway. A lot of the modern operating systems, if you sign into an account, it will back up things for you. And then when you reinstall, 5 minutes later, everything is back as it was. Because even the operating system folks go, yeah, your hardware is going to die and you will want it back in that same state, right? So we're even doing cloud stuff with the operating systems, right?
Yeah, absolutely. It's like desired state configuration, really. Like I store all my stuff in OneDrive, and just if I do, I make sure everything that's important is in there. So if my machine explodes and I need to do a new Windows install for whatever reason, I just have it all back within minutes or something. Or if I have a new machine, I just install Windows on there, and then everything just downloads back, and I just have everything where I had it. It's brilliant, isn't it?
Mm-hmm. Yeah, and we just need to take that, like you say, we need to take that attitude to the design of our applications. The thing that the application is running on is not going to be there all the time. And how do we work around that, right?
Yeah.
But then I guess so we kind of hinted at something earlier on. How do I, whilst I'm designing my application, how do I figure out which, let's go with Azure, right? Because we talked about Azure a lot. How do I decide which resources I'm going to use, right? I mentioned web app a whole bunch because that's kind of like the default standard. If you're making something for Azure and it's going to talk to the web, it's probably going to be a web app, right? But a web app is no good, really. Is a web app any good for a microservice? I've always thought it isn't. But is that what I do? Do I do something else? I mentioned Service Fabric. Is that something that everyone should know what it is and how to use it? Or like, how do you go about sort of the discovery of these services and figuring out what works for which solution?
Yeah. Well, what I try to do is I try to ask a couple of big picture questions about my application. And then with those answers, I can narrow down the services that I can pick from. And then I look at the requirements that I have and see if the services fit those requirements. So you can do this in many categories. For instance, like running your app in Azure, or storing data in Azure, or speeding up your application in Azure, working with messages in Azure, a whole bunch of things. So if you look at running your app in Azure, I ask the following questions. And the first one is then, how much control do I need? And that is the question of, do I need control over, let's say, the operating system? So maybe I need to install some weird legacy things or some third-party library to make my application work that doesn't work, let's say, in app service or in some higher level service. If that's the case, then I probably lean towards either a virtual machine or any of the container services. If I need less control, for instance, only over the configuration, like you just said, where you need to configure application services or connection strings, which you always have to do, of course, but you don't need control over anything else really, except for, of course, the application. Then you move on to platform as a service services or serverless services, which I like to call logic as a service as well. Things like Azure Functions and logic apps and stuff. And there's even times where you don't even need that much control, where you say, well, I don't really care. I just need the functionality of this particular thing. For instance, if you want to use machine learning as a service, like an Azure Cognitive Service, which are basically APIs that you call. You send them a photo, for instance, a picture, and then they send back a description of the picture, and maybe, well, we found 5 faces, and we found Jamie as well. Here he is. He is this tall. He's wearing glasses and he has a beard, for instance. That's then software as a service. So the first thing is to determine how much control do I need, which also determines how much responsibility you have over your service. If you need a lot of control, as in if you need control over the operating system, you're also responsible for the operating system. So you are responsible for patching it to make sure that it's all up to date, even for the antivirus that runs on the virtual machine. And if there's a virus on it that you might have installed yourself or comes from the internet or something. So you need to determine if you really need that type of control, because that also involves work and responsibility, which means that more things can go wrong and you need somebody to actually do that, which costs also money. So I usually tend to go up the stack if I can, with less responsibility and also less control, and let Azure handle running the things. But it depends, of course, on what you can afford to lose control-wise. So once you've answered that question, I usually go on to, where do I need my application to run? Is that only in Azure, in the cloud? Or maybe you also need it to run on premises in your own data center. Or maybe you want to, your CIO said, well, we need it to run in Azure, but also in AWS, because I don't really trust it only in Azure. We need a multi-cloud environment. Could be. Then you need something that runs both in Azure and also somewhere else. There are services for that. And then the next question that I usually ask is then, what usage model do I need? And this is then the question that asks, do I need this thing to run all the time, as in 24/7, so something all month, like a virtual machine or a web app, or is this something that is just a service or a task that runs occasionally, like when I upload an image that needs to be resized and put somewhere else, for instance. That doesn't have to run all the time. That only needs to run when I use it. So when I have things that need to run all the time, I have a bunch of services to choose from, like virtual machines, container services, web apps and stuff. And otherwise I choose from the serverless services. So these three questions I use to pick one of the services for running my application. Let me just sum them up, what they are, because there is lots of options. So you have virtual machines, like actual virtual machines that you can run stuff in. So those are on the spectrum of a lot of control and also a lot of responsibility over them. And then you have the container services. So you have Kubernetes service, AKS, Azure Kubernetes service, which you use to run containers, multiple containers, because that is a container orchestrator service. So it takes care of multiple containers and networking them together, and making sure that if one goes down, that it brings it up again, and when you deploy it, it meshes it all together, so you don't have to worry about all that. There's also container instances, and you use that to run a single container, just a one-off container that you run without a container orchestrator. Although you can combine the two, where you use container instances in AKS, but still it's a different usage model to run it in a container instance. There's also web apps for containers. That's also a single container that you don't need the container orchestrator for, and that uses web app features that you also find in Azure Web Apps. So you have deployment slots and other features like that. There's also Azure Batch, and you can deploy a container to Azure Batch, or you can use virtual machines with Azure Batch, which means you have a lot of control over that. And then Azure Batch, what it does is it takes whatever task you deploy, whatever little program task that you deploy, and it can run that on many, many nodes. So let's say 1,000 containers to scale that up, that task, and then string the workload all together. Let's say you're rendering a big movie file that usually would take days, for instance, to render. You can use Azure Batch for that, to just render that in an hour. You pay a bit more, of course, and then it scales all back when it's done, and then you're done with that. Then there's also Service Fabric, which you talked about. And Service Fabric is something that is a special service. This was publicly released 2015, 2016 or something. Microsoft has been using this service to actually run all of their services, or a lot of them. Like Azure SQL, for instance, that runs on Azure Service Fabric. So what that is, it is a reliable infrastructure where you can run workloads on. So you can deploy a service like Azure SQL, or your own web service, or even your own website to Azure Service Fabric, and it takes that, it replicates that a couple of times so that there's multiple instances of that thing that are running, and then it is reliable, it is up and running, it is highly available, it is performant, and you can update it as well. You can deploy a new version, and it just takes care of updating all of the little instances that are running there. It's basically magic, but you also need to make sure that you know how it works, because it's not a simple service to operate. I call it a little bit of infrastructure as a service, because there's lots of knobs to operate the thing, so you need a bit of infrastructure knowledge. You can imagine that that's true because they use it to run their infrastructure as well. But from the other side, it's also a platform as a service, because you can deploy your stuff to there, and then it just works. Because you can run this in multiple fashions. Service Fabric can run, you can install the Service Fabric runtime on your local machine, in your own data center, in AWS, or you use it from Azure as a service, and then you can use it as a platform as a service. And there's even Service Fabric Mesh, which is a serverless version of that, which means they take care of running the whole thing. You just deploy your services to it, and they just make them reliable and highly available and performant and all that stuff, which is amazing. So lots of options within that one service even. Then there's also cloud services. This is one of the first services that was released on Azure after Azure SQL, one of the first platform as a service services. You can use cloud services to deploy a website to it, a web app, or a background task, and it just runs those in, let's say, worker processes. This is a very old service. Do not use it anymore. Microsoft's not investing in it anymore, and they are advising you to use something else. So if you have a web application, just a web application or a background worker, you use a web app for that, an Azure App Services web app. Like we discussed before, that might be one of the most used services in Azure because it's so super duper simple. You just spin one up and you just deploy your application, your web application to it. Can be anything, can be .NET, can be Java, can be PHP, Node, whatever, it doesn't really matter. Microsoft's very inclusive because they want everybody to use this cloud, of course. It's their business model. Mm-hmm. And this thing can run reliably. Out of the box it does 99.99% with just one instance. You can set it to automatically scale when it gets busier. You can set it to scale when CPU load is high, when the HTTP queue is high, or whatever metric you can think of, or on a schedule. You get DNS, you get a domain name, you get TLS, all that good stuff. And then there's also deployment slots, which means that you can create another instance of the web app. You don't pay for that, that all runs on the same infrastructure. And then you can deploy a new version to that, a new version of your application, and test it before you put it into production. And once you think, well, this is ready, it can go into production, you perform what's called a swap. And that warms up the slot and warms up the production slot by hitting it a couple times. And then it just flips it around. It flips it by actually changing the IP addresses of the slot and the production slot. And then it's live without the user ever knowing that you're doing it. So with deployment slots, you can deploy with zero downtime, I always say. In the same family, you also have Azure App Services mobile apps, which is the same thing. You have deployment slots, you have domain names, TLS and everything. But you use this to host an API, a backend for your mobile application. So when you have a mobile app, runs on Xamarin or whatever it runs on, it always has some functionality that it uses from an API. And the mobile app, Azure App Services mobile app, is specifically designed to run such an API because it offers functionality like push notifications and offline synchronization. So when your connection goes down for a little bit, it can then sync back up through a little database that is on your device. And then it has some knowledge of what is synced and what isn't synced, so that it can do that. Clever service. So those are all platform as a service services, where you do not need that much control. You don't have as much control, but also not that much responsibility. So you just run it, and Azure just runs it for you. And when you need a little bit less control, then you can run serverless things, or logic as a service services. Those are things like Azure Functions. Everybody's heard of these. These are awesome. You use an Azure function to run a small piece of code. So you literally can create a function or a method that does something like resize an image and put it somewhere, and just put that in your Azure function, and Azure just runs that whenever you need it. And that's the beautiful of serverless. It doesn't run all month, but it only runs when you call it. So that means it might just run one time a month. It might run 1,000,000 times a month. And it only runs when you need it, and Azure scales it for you. So if it's being called 1,000,000 times at one point, then Azure tries its best, of course, and scales it out 1,000,000 times, which means you also pay for it then 1,000,000 times. Which is not a lot, actually, because you get, I don't know, don't quote me on these numbers, but I think it's 500,000 instance runs for free on the free tier or something. So you really have to do a lot of work in those to actually rack up a bill. And an Azure function is a small piece of work that you run whenever you need it. And then there's logic apps, which strings things like Azure functions together. An Azure logic app is basically an orchestration process, which previously we had BizTalk, if you remember that integration hell. That was horrible. Now this is all in the cloud, and you can just say, well, I want a new process, and I want this to run every Friday at noon, or whenever I get a new email, or whenever I find this message on Twitter, or whenever there's a new row in Azure SQL. All these things are taken care of. These are connectors that you can just use out of the box. You just configure them, thing starts running, and in the process you can call APIs, like an Azure function. When this runs, I call this Azure function, or I call this API, this connector, to send an email, or to call this custom API to do something. And it's just brilliant because these things run serverless, again, only when you need them. You don't need to pay for these things when they don't run. You only pay for them when they run. They scale automatically, and they are also reliable. So there's never been any logic app that hasn't been completed. It might have failed, the steps might have failed, but it will always run. Even if whole Azure goes down, whenever Azure comes up again, it will continue to run your logic app if it's not finished yet. So those are services that you can use to run your application. And like I said, you can use, if you need a lot of control, you use the infrastructure as a service services, so virtual machines, all the container services, sometimes service fabric. If you need less control, you use a platform as a service services, so cloud services, mobile apps and web apps. And if you need even less control, then you can use Azure Functions and also logic apps. And like I said, then you can choose where it needs to run. Is that only in Azure or is that somewhere else? If it is somewhere else, then you can run it in containers, for instance, because a container can run anywhere. You can have your container run on your local Docker in your local machine, or in AWS, or in your own data center, whatever, that runs anywhere. You can also run it in Azure Service Fabric, because like I just said, you can install the Service Fabric runtime anywhere, which means that you can run your applications anywhere. You can also run it in a VM, because a VM is just an image that you can run. You can install and run a VM image also on your local machine if you want to, or in another data center, of course. The other services, those are Azure bound. So Azure Functions, app services, logic apps, those are things that only run in Azure, which is fine, of course, but that's the choice that you have there. And then that other question is, how often or how do you want it to run? Is that all the time? Then you choose anything but serverless. If it is only when you need it, then you use the serverless services, so Azure Functions and also Azure Logic Apps. And once you've chosen all those things, once you've answered those questions, you end up with a couple of services. Maybe you end up, let's say, with all of the container services, and then you can go and choose from those. And you can do that then, well, do I need a single container? Do I need multiple containers and an orchestrator? Then you're looking at Kubernetes, for instance. Do you want things like deployment slots? Then you might look at web apps for containers. And then from there, you narrow it down even further. And you might end up with one or two. And from there, you can take a look at things like pricing, availability, performance, security, all the good things that you look at as a good solution architect, of course. And that's kind of the process that you need to take for this stuff. And this is then the extreme example, because running your application in Azure basically has the most services, and the other categories, like storing data in Azure, have a little bit less categories. And this is an example for storing data in Azure. By the way, I'm looking at slides here as well. I'm not just doing this all from memory, of course. But for options for storing data in Azure, you have Azure SQL Database, like we talked about. You use that for storing relational data, so tables with rows and columns. And other relational data stores are Azure Database for MySQL, Azure Database for PostgreSQL, Azure Database for MariaDB, because Azure is inclusive and everybody can use it. And then there is document data stores, like Azure Cosmos DB. Use that to store a document. You can get it out in multiple fashions, as in with a Gremlin API, Graph API, with a SQL API, with a MongoDB API even. But it all comes down to it is a document database and has a couple other tricks like active geo-replication and stuff. It still is a document database. And there's Azure Storage, which contains Azure File Storage, Azure Queues, which is also a storage mechanism, Azure Blob Storage, which you can use to store blobs of stuff. So also files, maybe an MP3 file or something. And then Azure Table Storage, which sounds like relational data because it is a table with rows and columns, but it is kind of loosey-goosey, semi-relational, because this table can actually have rows with different columns in it. So one row can have 10 columns, another row can have 1 column, for instance. Doesn't really matter. And then there's Azure Disk Storage also, which you use for virtual machines, for instance. And then on top of that, there's the big data stores, which is Azure Synapse Analytics. That was Azure SQL Data Warehouse. They just did a marketing thing where it now is called differently, but it does exactly the same. And there's Azure Data Lake Store. And Synapse Analytics, so Azure SQL Data Warehouse, that's relational. So that has tables with rows and columns, which means that before you use that, you need to define a schema. So you need to actually already know kind of which answers that you want the data to give you. So you know the questions that you want to ask of the data. And Azure Data Lake Store is a document database where you can basically store anything in there. So that's more of a store where you store data that you don't really know what kind of information you want to get out of there. You don't really know what questions the data will answer beforehand, because you can't really create a schema for that. You don't have to as well. And that's then the options for storing data in Azure. So how you choose between those, like I already said, you first need to know, well, am I going to use a document database, or am I going to store relational data? Is it going to be a normal application that I'm going to build with this? So a online transactional processing application, as in forms over data, or is it something that I use analytics on, which then you look at the Azure Synapse Analytics and Data Lake, so big data things that you use analytics on. Those are the big questions that you ask there. And from there you can then filter the choices that you have, and then again look at the requirements. So look at pricing, availability, other tricks that they have, geo-replication, stuff like that. So that's just basically my process for filtering all this stuff. And I've also created a course on Pluralsight where I go through all of this stuff. And these were just 2 categories, but there are like 10 or something, including speeding up your application, working with messages, securing your application, deploying your application, you name it. There's so much. But that's basically the process that I then go through as well.
Sure, because that's one of the things that I mean, even if we kept going, there wouldn't be enough time to talk about. But like, there's things like network transports and firewalls and all kinds of lovely, wonderful ops things that you don't really need to mess with. But if you desperately wanted to, say, lock down access to your system to a certain IP range, or to within Active Directory, or to certain users, then you could totally do that too, right? And yeah. I guess it's just a case of just figuring out what there is and what you need, right? It's all talk to your clients or customers and find out what they want.
That's the thing. It's all about the requirements. So if you need this to not be available on the internet, but only within your intranet, let's say, then you need different services. So you could do that with web apps, for instance, with Azure App Services web apps. You might need to choose a different tier because you have an isolated tier that puts all this stuff within a boundary of a virtual network and a firewall around it. But like you said, there's also services that can just do that. You have virtual network services. There's all sorts of stuff. There's peering, there's firewalls, there's Azure Front Door, which is something that you can put in front of a web app, let's say, to filter traffic and to route it. There's Traffic Manager. There's all these more opsy things as well. But what you pick there, again, it all depends on what you need, on what the requirements are. So, therefore, it's also always important, what I think, when you talk to the client in the beginning and during the project, to involve your ops team, your infrastructure, your DevOps team within the requirements gathering. Because usually that's forgotten. Like, all right, tell us what the application needs to do, tell us what the UI needs to do. That's usually what we're talking about. And then later on, we might talk about, how fast does this thing need to be? How up does it need to be? Can we update it on Sunday or something, where we have it down for 4 hours? Stuff like that, because that determines everything else. That determines basically everything, really. That determines all the services that we can pick. But usually that's left to after the requirements phase.
Sure. I know that a friend of mine just sort of there's so many things to choose from, right? And one of the things that you mentioned earlier on was this idea of logic as a service, the sort of the function stuff. And I know that a friend of mine effectively runs his business through logic apps. So like where previously you would have a virtual machine on one of his on-prem servers with Hangfire sitting and doing nothing until Friday evening and then doing a bunch of stuff. He now has a logic app that doesn't even practically doesn't exist until seconds before it needs to run. And then it exists and does its thing and then disappears from the face of the planet, right? And he does things like when one of his clients emails him for a report, he has his emails hooked up to a logic app. And if he comes in asking for a report, it fires off an application that builds the report for him and replies back with, here's the report. So he never even sees those emails. And things like invoicing people, every Friday it runs out all of the invoices and just sends them off. It's wonderful. And it costs him nothing because it's all part of that free logic tier. It's wonderful. Just the breadth of what you can do with Azure is just amazing.
And over the years, because of the competition that the big players have, so AWS, Google, and Microsoft, prices have gone down significantly. Not only because of the competition, but also just Moore's law. Things are just way cheaper. So storage costs nothing. Compute is starting to come down as well. And because of all that, it is so easy now to run an application or a business within the cloud. Because like you said, you can do it for next to nothing. If you're a bit clever, you pick the right services. Even if you run, let's say, an application in a web app all month, it's not that expensive, not really. So you can run your whole startup just in Azure without it costing that much, Azure SQL database all month, $5, €5. Nothing.
Exactly.
Capabilities that you get, incredible. You go and run a SQL server somewhere with licensing. Go do it. See what it costs on premises. It's crazy.
Mm-hmm. Yeah. There's even there's an episode that will come out before this one with a developer from the UK called Andy Morell, who's part of the Live Coders crew, and they ran 2 live conferences over Twitch using a VM, and it cost them £50. That's it, just to run this entire conference, this 48-hour conference, £50 because they spun up a VM, ran everything through it, and then shut it down again. And
there you go.
It's wonderful, right?
Yeah, it's such a good enabler. It enables us, all of us, to use this incredible infrastructure that's just out there, because it's now accessible to everybody. And there's lots of plans that you can use as well to make it even cheaper. When you could, for instance, pre-reserve a bunch of resources where you say, well, I know I'm going to use £1,000 worth of stuff this year, so I'm going to pay you that already, prepay it, and then you get a discount, usually pretty significant as well. So there's lots of options there.
Yep. And like you say, there are some services that require you to say upfront what you're going to do or which technology, but the majority of them are like with the web services, right? I keep coming back to that one because that feels like Azure easy mode. You just throw something at it and it just figures it all out. Like I can write something, like you said, in PHP, Python, Node, .NET, anything, as long as it's got a web server, throw it at it and it just runs. I don't need to tell it what it is. Just like, here's the directory with the binary in it. Go figure it out. And it figures out the runtime and all this kind of stuff and wiring everything up. It's absolutely wonderful.
Yeah, well, you do need to do something. Let's say if you run something other than .NET in an Azure Web App, you need to flip the switch there where you say, well, this is the runtime that I actually want to run on. But apart from that, it does everything by itself. Yeah. It's a wonderful, brave new world that we live in. It's amazing.
It really is. So you talked earlier on about you've done a whole bunch of Pro site courses on things related to Azure, picking the right resources and all that kind of stuff. I was wondering, I'll get a link from you to put into the show notes, but what are other ways that people can find out more about you and the things that you're doing? Is there a blog? I know that you do a podcast, but other than the podcast and like Twitter, what's the other way to find out the best way to find out what Barry's up to?
The central way to find me is azureberry.com. That is my blog, and through there you can also find my Twitter and LinkedIn and all that good stuff. And also my podcast, like you mentioned, thanks for the plug there. That is a relatively new podcast called Developer Weekly. You can find that just in any podcast app or at developerweeklypodcast.com. And that's, well, you thought it probably, it's a weekly podcast for developers. So we talk about stuff like we talk about today. .NET as well, and very broad. Azure as well, AWS, whatever. And from there also you can find me and my Pluralsight courses as well. I have lots of courses about Azure, as in, I am Azure Barry, but I also have courses on other stuff like JavaScript, HTML, continuous integration, continuous delivery, things like that.
Excellent. Okay, well, I'll make sure to put links to all of those things into the show notes. So if you are listening along, please click through and you'll find them, along with a full transcription as well. But yeah, all that really remains to say, Barry, is thank you ever so much for coming on to the show and talking a little bit about Azure. And I feel like you've said a lot, but I feel like this is just a little bit about Azure, right? It's a huge topic.
We've barely scratched the surface. Yeah, you're absolutely right. Yeah, it's so incredibly huge. It's an art in itself. It's a whole technology field in itself. But the thing is, it's fun to get into, but you don't really need to do that per se. If you just focus on building your app, that's absolutely fine. Because if then the DevOps person in your team, for instance, knows how to push this to whatever thing that your architect or whatever has decided, then that's fine too. Because it will just run there. And like I said, if you then focus on running your app and making sure that you don't store anything locally and use cloud design patterns like retry and stuff, which are all baked into the standard libraries, you're fine and it will run.
Excellent. See, I love that parting shot of wonderful advice. I love it. This is why we do the podcasts, right? To get all of these wonderful nuggets of advice and share them around, because it's best that people know about these things. It took us all years to figure them out, so let's share this information. Yeah. I like it. But yeah, like I said, Barry, thank you ever so much. It's been wonderful talking to you, and I've learned a whole bunch about Azure. I now know that Azure is a little bit more than just web apps.
Thank you very much for having me.
You're very welcome. Thank you. That was my interview with Barry Luijbregts. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or review in your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Ltd.